All right, good morning, good afternoon, good evening. Whenever you're watching this video, I hope you're doing great. So we've been talking about proving triangles congruent for a while now, okay? We've talked about how to prove them congruent with side, 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 angle, side, and angle, side, angle, and angle, angle, side, okay? And so hopefully you guys have that down pretty well by now. And so we're going to move on to the next phase of this. And so what I want to do is I want to step back a couple of days to where we began chapter 4, and I want you to think about what we talked about when we talked about congruent polygons. We said that congruent polygons have congruent corresponding parts, right? Okay, their corresponding sides are congruent, their corresponding angles are congruent. Okay, so let's think through this for a second. If I go ahead and prove a pair of triangles congruent by side, 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 I then know that all those corresponding angles have to be congruent, correct? Okay? And if I go ahead and prove a triangle congruent by, let's say, angle, side, angle, I then know that the third angle is congruent and the other two corresponding sides are also congruent, okay? And so if that doesn't make sense to you, this next part definitely won't make sense. But here's what I want you to see. At the top of your paper there, it says this: once you've proven triangles congruent, I'd like you to go ahead and take your highlighter or your pencil and just go ahead and say, yes, this has to be true in order for anything that we do today. Okay? If we haven't proven triangles congruent, what I'm about to talk about cannot be true. Okay? So if the triangles are congruent, the conclusion is going to be you can conclude other things about the other parts of the triangle. So by definition, congruent polygons or triangles, we can use this acronym Cpctc. Corresponding parts of congruent triangles are congruent. Okay? Now you may want to pause there for a second and add that to your vocabulary sheet if you didn't add it the other day. It is something that you have got to memorize within this chapter here. Corresponding parts of congruent triangles are congruent. Okay, so how are we going to use this? Well, if you look at the very first proof that we've got here, we've got a pair of angles congruent, and I think just by looking at the picture, most of us are going to identify what other parts are going to have to be congruent. So hopefully it just hopped into your head that you know that FH is going to be congruent to FH by the reflexive property. Okay, and once you've jotted that down the proof, you always want to go ahead and add that to your diagram. Okay. Now, is there anything else we can prove congruent? Not at this time. But the good news is we have congruent triangles right now. Okay, and hopefully you're thinking, yeah, the triangles are congruent by angle, side, angle. So I'm going to write that down, angle, side, angle. Okay. And then you'll want to match up the corresponding vertices correctly. If I was doing this, I'd probably do something like this. Triangle FEH is congruent to, now think for a second, F would correspond with which vertex from the other triangle? Well, that would be H, because there are only one congruency marks as far as their angles are concerned. Okay. E would correspond with G, well, that was easy, and then the last one would be F, H, G, F, F, E, H. Okay. So that's what we've been working on so far, and that's where we finished up most of our proofs, and we'd be done by now. But the thing is if you look at number 1, what are we trying to prove? Well, we're trying to prove that HE is congruent to FG. Well, in order to do that, I have to add another step here. Okay, and so this is what I was talking about a moment ago. Once these two triangles are congruent, this triangle to this triangle over here, all right, I then would know not only that HE is congruent to FG, I would also know that HG is congruent to EF, and I would also know that angle E is congruent to angle G. Okay? All of that's going to be true because the triangles are already congruent. Now, what do I have to prove congruent? Well, all I have to prove congruent as of right now is just that HE is congruent to FG. Okay? And so that's what I'll put down here. Because of this, I know this is true. HE is congruent to FG. And what's my justification always going to be? Corresponding parts of congruent triangles are congruent. Okay? Congruent triangles. That took place right here. So now I can go ahead and state this down here. Okay? I never, ever, ever want to see you put this as a justification prior to proving triangles congruent. Because if you do, that just tells me you have no idea what that means right there. Okay? So again, corresponding parts of what congruent triangles have to be congruent. Okay? All right, let's go on to the next one here. Taking a look at, see if I can get this to scroll down here. Oop, here we go. Okay, the next one, we're going to prove that Vx, so this segment right here, is bisecting this angle right here. Okay? All right, now, before we're going to do that, though, we're actually going to go ahead and prove the two triangles congruent to each other. So, let's go ahead and do that. Well, what parts from the two triangles do we know are going to have to be congruent? Well, I know that they share a segment here. They share Vx. So hopefully you guys already marked that down because you saw that right away. And I'm going to put down Vx is congruent to Vx by the reflexive property. Okay. Now, as you look at that, I'm hoping that you're thinking, man, that was easy because now I have congruent triangles. By what reason? Side, side, side. Okay. And so you can go ahead and put down a congruency statement if you like. It does not have to be the same as mine up here. Just make sure you match up everything correctly. I'll go ahead and say triangle VUX is congruent to triangle VWX. Okay. Those two are congruent to each other. Now from there, I would then know that this angle would be congruent to this angle here. That's kind of sloppy. This angle is congruent to this angle here. And that this angle down here would be congruent to that angle there. Because the triangles are congruent, all the other parts have to be congruent, right? Well, one of those three things is going to help me prove that Vx bisects angle UXW, okay? So which one of those three angles is going to help me prove that this segment right here is going to bisect this angle right here? I hope you're thinking to yourself that that angle has to be congruent to that angle, okay? Remember when we talked about bisecting, it's to cut in half. And I've really been stressing that if I'm going to do this, I would point that arrow right at that angle. Because a lot of times students get confused. If you bisect a segment, you have two congruent segments. When we're not bisecting a segment here, we're bisecting an angle. So if we bisect an angle, we have two congruent angles. So the fourth step, I'm going to put down here that angle UXW, I'm sorry, UXV, get that right here. UXV is going to be congruent to angle WXV. Again, by corresponding parts, which those two angles are, they are corresponding parts, sides and angles will be the parts part, of congruent triangles, which we've already discovered there, are congruent. Okay? Now, unlike the last proof, we were done at this point, but the proof is actually to prove this up here. Okay? And so, because of this, if those two angles are congruent, I know that this has to be true. That Vx is going to bisect angle UXW. Okay? And what's my justification for that? Well, remember when I asked what would have to be true in order for this to be true? And we talked through that in order for this to be true up here, that this right here would have to be true. Okay? And where did that come from? Well, it all came from our understanding of what it means to bisect something, to cut it in half. So they're two equal parts. So I'm going to put down here definition of bisects. Okay? And so as a result, those parts are equal. So yeah, I hope that made sense to you guys. Came back to that definition there. Let's go on to the next one. Okay. And right about now, I'm thinking that some of you guys probably can solve these proofs faster than what I'm putting up here. Okay, so what I would encourage you to do is try to solve this proof on your own. Okay, the big thing here is this. Obviously, you're going to prove triangles congruent, but the question is, what would have to be true in order for this to be true? Okay, so pause your computer, see if you can write it out. I have down here 5 steps. Okay. And then maybe fast forward to the end and see if you did everything correctly. Okay. All right. So as I look at the triangles over here, I think that most students are probably going to say, yeah, I know I have a pair of vertical angles congruent. Okay. So I'll just go ahead and put vertical angles are congruent. Okay. Now, I'm a little leery. Some of you still don't identify those vertical angles very, very well. All right. I'm going to go ahead and mark them out congruent right there on my paper. Okay. But to identify those angles, you would want to say something like this. Either angle YAZ or angle ZAY. I'll put ZAY down. Is going to be congruent to either BAC or angle CAB. I'll put angle CAB down. Okay, so that's how you'd want to identify those vertical angles there, because there's multiple angles at angle A. Okay. Now from there, do I have congruent triangles? Yeah. By what reason? Well, I hope you're thinking to yourself, angle, side, angle. Remember, it's got to be the side between those two congruent angles there. Okay. So from there, match up your corresponding parts. Well, if I go ahead and say triangle ABC is congruent to, oh, I forgot the C, there you go, is congruent to, it would have to be AYZ. Okay, those are the two triangles that are congruent there. All right. Now from that point, now it's just a matter of asking ourselves what would have to be true in order for A to be the midpoint of ZC. Okay. Well, in order for A to be the midpoint of ZC, okay, what would we have to know about these segments here? Well, wouldn't they have to be the same length? Because to be the midpoint is to be equidistant from the endpoints of the segment. Okay. So what I'm going to do is I'm going to go ahead and say, you know what? Since these two triangles are congruent to each other, I know that ZA and AC have to be congruent. If I look up here, ZA and AC, you know what? They're in the same positions within my congruency statement, so they have to be the same length. So I'm going to go ahead and say ZA is congruent to AC by CP, corresponding parts. These segments are parts of the two triangles we talked about, of congruent triangles. Well, we've already proven that up there, are congruent. Okay? So Cpctc. Now, if those two segments are congruent to each other, can I state that A is the midpoint of ZC? You betcha. Okay? So I'm going to put down, I should probably put down point A is the midpoint of ZC. Okay. Now, what led me to that conclusion? Well, by definition of midpoint, those two segments ZA and AC would have to be the same length. Since they are, I know the definition is true, holds true here. So definition of midpoint. Okay. So again, one of the things I tried to stress to you guys at the beginning of this chapter is these proofs, there's a lot of stuff in common. And there's kind of a sequence to them. And if you can start to reference that sequence, you see it's not that hard. So, all right, let's take a look at the next page now. Okay. And let's go ahead and, again, this one's a 5-step proof, just like the previous two. And I think you guys can probably go ahead and solve it on your own faster than I could. So again, give it a shot, pause your computer, see what you can do, and then fast forward to the end of this proof and see how you did. So, all right, I look up there and I think you see the reflexive property, PR is congruent to PR. Okay, well that was simple because that led us to congruent triangles. By what reason? Well, I hope you see side, side, side there. Okay. Now I've noticed in the past when students have had a problem like this on the test, they struggle a little bit matching up the corresponding parts of the two triangles. Okay. So if I go ahead and say NPR, National Public Radio, oh, I'm sorry, these acronyms get me thinking of different things. So NPR, okay, is congruent to, now N to P is 2 congruency marks to 3 congruency marks. So if I start at Q, go 2 congruency marks to 3 congruency marks, QRP. Okay. All right, now I've got congruent triangles there. So that means I can start to identify some congruent corresponding parts that would lead me to this. NR is going to have to be parallel to PQ. Okay. So I'm gonna get rid of that. I'm gonna do both those. Okay, I'm gonna highlight this. See what this will look like. This side here needs to be proven parallel to that side there. Okay. So we've talked in chapter 3. We've been talking about angles that influence those parallel lines, and hopefully you're already thinking to yourself, these angles have to be congruent in order for those lines to be parallel. But let's talk through which angles exactly. So as I look at this picture here, this angle right here and this angle right here, they don't have any relationship between each other. They don't share a line. Okay, so there's no transversal, no relationship. So those two can't be the two that we want to prove congruent to make those lines parallel. As I look at this angle right here and this angle right here, well, they share a transversal and they're alternate interior angles, but the problem is that this angle right here influences the transversal in this line down here, and this angle right here influences the transversal in that line up there. So those two aren't the ones that we want to prove congruent. So by process of elimination, it must be this angle here and this angle right here. Now, here's what I want you to see. Being that those are alternate interior again, and they're congruent, they influence the transversal, and this angle influences this line, and this angle influences that line. So therefore, these are the two that we want to prove congruent to each other. Now, let me go ahead and clean this up a little bit so we can see this a little bit better. Okay. So 1, 2, 3. Here's the angles that we want to prove congruent in order to make those lines parallel. So I would go ahead and say something like this, angle NRP, again, because there's multiple angles to R. There's 3 angles there to R, so make sure you use NRP, is congruent to angle QPR by Cpctc. Every time you write that out, think to yourself, corresponding parts, which the angles are, they're corresponding parts, of congruent triangles, which we've proven up above, side, 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 are congruent. That's how I know they have to be true. For number 5, I then would know that NR is going to be, sorry guys, I actually touched a button on my pen that made things go crazy. NR is going to be parallel to PQ. Okay. And here's going to be your statement. It's either going to be this. If lines are parallel, then alternate interior angles are congruent, or if alternate interior angles are congruent, then lines are parallel. Now I want you to think about the process here. We're starting here, which leads us there. So which statement do I want to use? Well, what type of angles are those? Again, they're alternate interior. If alternate interior angles are congruent, then lines are parallel. okay? And that's my conclusion. My conclusion is that those lines have to be parallel to each other, okay? Very good. I hope you're picking up on this. I really enjoy doing proofs because they're, like I said, they're a puzzle, and they can oftentimes challenge me if it's a really good proof. So, all right, the last one here has some different things in it, and there's really no way to go straight to the fact that we have congruent triangles. It's going to take us a little bit to get to that point. So if I was probably you, I would probably look up at that diagram before I even looked at the given and say, you know what, I know something to be true. I know that I have vertical angles congruent. So what I'm going to do, I probably should write this down in my proof before I mark it my picture, but I'll mark it in the picture first. I'm going to go ahead and say this: angle ACB is going to be congruent to angle ECD. Okay. And I'm going to say because vertical angles are congruent. Okay, so that was pretty simple there. Now, as I look at my given, they marked out the given in our picture over here. I will never do that for you guys, okay? I'm going to try to give you clean pictures, and I want you to be able to read the given and put it into the proof, okay, the diagram. So as I look up here, and they've already marked out BC is congruent to CD, okay, so that was nice. And then I see these upside down T's. Now, I think you guys have this definition down pretty good. The fact that we have perpendicular lines there. So it says BD is perpendicular to AB, okay? And they went ahead and marked this right angle out already for you. I would never do that because I'd want you to interpret that for me. They also say BD is perpendicular to DE, so we have the right angle down here as well. So what I'm going to do here for a third step, I'm going to go ahead and put down that angle B and angle D are right angles. Okay. Now, how did I know that? Well, it was by the definition of perpendicular. Okay. I don't want you ever telling me that the angles are congruent, because by definition of perpendicular it just says two lines intersect to form right angles. Okay. It doesn't say when you have perpendicular lines all their angles are going to be congruent. Okay. It says that they intersect to form right angles. So from there, I hope that you're thinking, well, it's kind of redundant to state this, but angle B has to equal angle D, right? And that's true, but in a proof you want to write that out so that the reader can see that. So angle B is congruent to angle D. Why is that? Well, you could write down because they both equal 90 degrees. I'm going to write down in a more formal way, all right angles are congruent, but I would accept either way. Okay. All right, now as I look up there, the question becomes, do we have congruent triangles? And yes, we do. By what reason? Hopefully you're thinking angle, side angle. Okay. And so I'll go ahead and put down here, let's see, triangle ABC is congruent to triangle EDC. Okay. And then as a result, I would then know that angle A is congruent to angle E, again by Cpctc. Okay. Now, as I was just writing that out, I'm thinking to myself, you know what? There's a faster way to prove those two angles congruent. Okay. And that's what's kind of cool about a proof, in the fact that you don't have to go one strict way. Some proofs, yes, it leads you down one direct path. Okay. But there are some other proofs, if they're good, it opens up. And some people can solve them in 3 steps, and some can solve them in 6, like I did there. Here's what I'm referring to in this problem. If you were looking at what you had up here, okay, you could go ahead and say this. Well, with these two angles being congruent, I would then know that this line is parallel to this line. okay? Because they're alternate interior, they have to be congruent, and leading us to parallel lines. And then after that, if those lines are parallel, I could then state that this angle would be congruent to that angle, okay? So that'd be another way you could have done that there. I'm not sure how many steps it would be. I didn't actually write that out, but that's another possibility. Here's another possibility. After you've stated the vertical angles and the fact that these two angles would be congruent, like we did here, so that step there, and that step there, technically you could jump right to the fact that angle A is congruent to angle E, because if two angles from two triangles are congruent, then the third angles are congruent. So again, be creative with these. Don't think I have to give Mr. Couples exactly what he wants to hear, because maybe there's a different way that I hadn't considered before. The only the only mandate I'm going to give you is operate within the laws or rules of geometry. Okay? Don't make up your own rule in the fact that you believe something is true. Make sure it is true before you state it. Okay? So I appreciate you guys paying attention there. If you have any questions, let me know. But the homework is on the calendar, and I need to see the notes when you're done. Thank you, and good night.